Okay, so here we have a question about the structures of a nature park and where they are placed. Okay, this is one of our criteria D questions for coordinate geometry. So part A wants us to calculate the distances between each of the points. Okay, so the first distance I'm going to find is between A and B. Okay, my coordinate of A is 1, 2. My coordinate of B is 5, 7. I'm going to label them as x1, y1 and x2, y2 just to stop me getting confused. Then I'm going to use my distance formula, which I've already written here. Okay, and it's just a case of substituting in to my formula. So x1 is 1, subtract x2, which is 5, all squared, and then we're going to add y1, which is 2, subtract 7, all squared. Okay, so AB is equal to the square root of, we're going to have -4 all squared plus -5 all squared. This is equal to the square root of 16 plus 25, so the square root of 41, which as a decimal, you will want to pop this into your calculator. And if it comes up with a fraction or a third, you just want to hit that S to D button. Okay, and you should find that it is 6.4 units as a decimal. Okay, so that's the first one done. Then I'm going to do B to C. So BC, again, I'm going to write the coordinates underneath just to remind me. So 5, 7 and 9, 2 this time. So we have x1, y1, x2, y2. Okay, that would be equal to the square root of 5 minus 9 all squared plus 7 minus 2 all squared. So BC is equal to the square root of, it's going to be -4 all squared plus -5 all squared. Oh no, sorry, not just 5 squared this time, which would give us the same answer of root 41, which of course is 6.4 units. Okay. And then the last length that I need to find would be between A and C. So just repeating this process. x1, y1, x2, y2, just so I don't forget when I put into my formula. Remember, showing all your steps of working out helps you not to miss out marks or make any mistakes. Okay, so let me calculate this one. I'm going to have AC is equal to the square root of -8 all squared plus 0 squared. Okay, it's going to be the square root of 64, which is 8 units. Okay, so that is part A done. Okay, now on to part B. It asks us to determine the perimeter of the triangle. So you're going to want to add the 3 distances that you've just found. So perimeter is equal to AB plus BC plus AC. Okay, so if I fill in what I know, so P is equal to 6.4 plus 6.4 plus 8. So the perimeter is equal to 20.8 units. Okay. That's that part done. So that's A and B done. Let me just make this a little bit smaller to give myself some room for part C. Okay. So on to part C. Now it's asking us to find the equation of the line that connects point A and B. Okay, so A is 1, 2, B is 5, 7. We're going to need to use our gradient formula here first. So M is equal to y1 minus y2 over x1 minus x2, or you can write it as y2 minus y1 over x2 minus x1. Lots of people ask me this, but it gives you the same answer, okay? As long as you keep either both of the y1 x1 first or y2 x2 first, okay? So let's work out the gradient. So m is going to be equal to 2 minus 7 divided by 1 minus 5. 2 minus 7 is negative 5 divided by negative 4. So here our negatives cancel out. Okay, so our gradient is equal to 5 over 4. Now what I need to do is substitute in to the equation of a line. Okay, and I'm going to pick one of the coordinates to use as well as my gradient. So far I've got y is equal to 5 over 4x plus c. Okay, so I'm going to use my a coordinate here and substitute that in. So y is 2, 5 over 4x is 1, and then we have plus c. So 2 is equal to 1 letter 5 over 4 plus c. You might benefit here from changing 5 over 4 into a decimal. Okay, so let me just rewrite that. 2 is equal to 1.25 plus c. You're going to subtract 1.25 from both sides, and you will find that c is equal to 0.75 or 3 over 4. Okay, now you do want to come back to this equation here and make sure that you write in your c value as well. Okay, so plus 3 over 4 so that you have your completed equation of a line. Okay, now we have it.